Okay, and I think with this we should also switch to English.
Perfect.
It's perfect. Okay, very good. So our today's topic, which we will discuss before we go into code, is data binding. This is what I want to discuss with you. So we will need data binding in our final exam, and therefore we have to discuss how data binding really works and why we really need it, okay? Let's think about the different components that we need whenever we do, we want to bring something on the screen. What is happening behind the scenes? Let's think about the different layers here. First, we have here the screen. If we think about WPF and XAML, who is responsible for drawing the pixels on the screen when you build applications, desktop applications, for Windows, for instance, using WPF and XAML? Who paints the pixels on the screen? The graphics card. Okay, yes, that's clear. Let's go one step above. Who controls the graphic card? Windows, the Windows driver. Yes, of course. How is this Windows driver called in WPF that draws the pixels on the screen? What is the important subsystem that you need in Windows when you play a game on Windows?
DirectX.
Exactly. It's Direct3D, DirectX. The Direct3D subsystem in Windows cares for drawing pixels on the screen. Correct. So what we have, we fill the screen with Direct3D, DirectX. Exactly. This paints the pixels on the screen. Now, you, as a developer, you are not writing direct code interacting with DirectX, correct? But what do you write? You write XAML in WPF. So somewhere here on the left-hand side, we have WPF, and here we have XAML, XML Application Markup Language. Now, what is this XAML all about? What does this XAML really do? You describe the logical structure of the user interface in the form of XML code. So maybe on top you have the first element, which is a window. This window might consist of, here, a panel like a stack. So you are logically describing how the tree, the logical tree, looks like. This is what you, as a WPF and XAML developer, really do. In the background, the thing is way more complicated, because if you, for instance, think of the combo box itself consists of multiple elements. So let's make it simpler. Let's think about the button. You, as the developer, you just say, I want to have a button. But behind the scenes, the button consists of a border, so you are just defining a logical tree, and behind the system, behind the scenes, WPF has a so-called templating system which fills in the blank. So WPF knows how a button looks like, and it knows it because somebody at Microsoft, at Redmond, wrote a template that told WPF that a button has a border and a text block or an image. Understand what I mean? It's becoming even more complicated if you think of something like a combo box, because a combo box also might have the border. You can click on this button to open the combo box, and the combo box contains a repeated set of elements. And these elements can again be complicated things. They can be a text block, but they can also consist of an image in a text block. They can even consist recursively of another combo box inside of the combo box. Understand what I mean? So at the end of the day, you have a non-trivial tree of elements describing logically the content of your user interface, and by applying templates, you get the blanks filled in. So you as a developer can just say, give me a button with that text, and the templates generate the rest. Just an important note, of course, you can influence the templates. In WPF, you have a really powerful templating system, and you can build so-called data templates and control templates where you can completely redesign everything from scratch. So buttons do no longer look like usual buttons look like. You can do that. We will not do that in this course, but it is definitely possible. Remember that, okay? My question is, how does WPF and XAML get from there to there? How do we get from the logical tree to DirectX to the pixels? It is a declarative system. You are not telling the system imperatively how to draw pixels for a border, for instance, to DirectX. This has been done by Microsoft. So WPF contains logic where the smallest elements, like borders, rectangles, circles, text elements, fonts, and so on, are transferred to DirectX. And when you manipulate something like this, for instance, if you delete this text block from the logical tree, it automatically recognizes that something in the logical tree has changed and triggers a redraw of the screen here using the Direct3D DirectX system. Understand what I mean? You do not have to do that manually. In former times and in other UI frameworks, you're responsible for drawing something on the screen. Have you ever heard, for instance, from in browsers about canvas-based games? The canvas system. There you can influence every single pixel. If you build a game, you really want control about every single pixel. This is not necessary in WPF. WPF is not such a canvas-based system where you draw every single pixel. You just describe what you want to have, and somebody else, WPF, is responsible for turning that into the pixels. And again, and this is the important thing, if you manipulate something, the user interface is automatically updated, automatically refreshed. It sounds trivial, but it's really complicated that this runs efficiently. By the way, in WPF, the system of transferring this logical tree into screen renderings is super powerful. You can really use the power of a 3D engine. You can take, for instance, a sphere, Kugel. You can take a sphere and use the description of your input formula, of your input form, as a texture on top of the 3D sphere and let it rotate in space while you ask the user to enter something in the input fields. WPF is perfectly capable of doing that. Because at the end of the day, it has a very powerful 3D capable engine behind the scenes. And it can project, it can rotate, it can manipulate in 3 dimensions. It has support for meshes, you can change lighting, you can move cameras around while you are using these logical trees and project these things onto some 3D things. So it's super, super powerful. You rarely need it, to be honest. Yeah? Nobody does that. But it is generally possible. It's not very useful, granted, but it's possible. Okay? Good. So remember that XAML WPF logical tree translated to the pixels on the screen using Direct3D. The problem is we have here a large blank space, and this blank space is your C# code. How do you manipulate this logical tree in C#? The first option is you use imperative code. Imperative means that you explicitly write code where you tell WPF how to manipulate this XAML code. So you are getting a reference, for instance, to this text box, and you can manipulate the content by saying my textbox.text equals to foobar. With that, with this imperative code, you change the logical tree The change of the logical tree is automatically detected and updates the pixels on the screen. This is imperative code, and you should not do that. This is the exception, not the rule. You should never directly access a XAML element and manipulate it. That's old style. When I was in the school and graduated from the school, this is how we did it. We wrote code that grabbed some elements from logical trees or from the UI and manipulated it. You shouldn't do that. That's old style. The correct thing is that you do data binding. What does that mean? You have objects here in C#, and you bind certain properties of these objects to certain properties in the WPF and XAML tree. So you might have here a property, and you tell WPF that this property is bound to a certain property here in this text box. So when you change the property here in C#, WPF, the binding is an object on itself. It's really, imagine like if you marry somebody, you get a wedding band that you have on your finger, and this binds you to somebody. It is a thing. The wedding band on your finger, it is a thing. Binding is really an existing object. You create the binding object in WPF. And this binding recognizes whenever you change something here, how this is done, we will discuss that in a second, and transfers the change in C# into a change of a property in the text box. The change of the property in the text box triggers a redraw on the screen. Understand what I mean? The important thing that you have to understand and remember, the binding is a thing. It is an existing object. The object is called binding in XAML and C#. So instead of just having a string as a property here, textbox.text is usually a string, right? But in this case, you tell the textbox.text, hey, your content is not a text, but your content is a binding. And this binding now has a connection to C#. Now, how does C# and XAML recognize changes of these properties? It uses a very specific interface. Who can remember the interface that is used to recognize changes in C# that trigger changes in the logical tree, that trigger changes on the UI? Exactly, that's the point. You have to remember that. That's the important thing. You need that in order to survive the Matura. INotifyPropertyChanged. So let's write it down here. I wrote an abbreviation here. It's really called property changed. Okay? There is a second one. If you don't have a property but a whole collection, for instance, for a combo box, then you need which interface? Not INotifyPropertyChanged, but INotifyCollectionChanged. Exactly. And there you maybe have in mind, we had that in the first semester, that there is a collection which is called ObservableCollection, and this automatically implements the INotifyCollectionChanged. If you do not implement INotifyPropertyChanged, then WPF will not recognize a property change in C#, will not update the property in the logical tree in WPF, will not update the user interface. You will simply see no change. It cannot magically recognize that you change something in C#. Binding, you see it here, can work in both directions. We can have a binding where you change something here in C# and you want the change automatically to reflect in the logical tree. That would be a one-way binding from C# to WPF. One-way binding. You can also have the other way. If you change something here, the user interacts with the screen, clicks inside the text box, and change the content of the text box by typing something in. Then you have a binding from the logical tree back to C#. And if you want to have both, change something here, this changes. Change something here, this changes. Then we are talking about the two-way binding. The WPF binding supports both. Question: for what do we need INotifyPropertyChanged? One-way binding from C# to logical tree, or one-way binding from logical tree to C#, or for two-way binding? Exactly. If you want to have the user interface to be automatically updated when you change something here, then you need this interface. If you want to have a binding back or a two-way binding, well, for the two-way binding you need it too, because that has an aspect from here to here. But if you just are interested in something that flows back to here, then you don't need INotifyPropertyChanged. INotifyPropertyChanged is really just a helper to enable WPF to recognize C# property changes. Because there is no other possibility. What would WPF need to do in order to find property changes in C# without this interface? It would have to poll. Every few milliseconds, it would have to compare, has any of the properties changed that play a part in data bindings? And if something has changed, it would need to update the screen or the logical tree. And that will be what? Horribly inefficient. And therefore, it becomes pretty fast and efficient by having this interface, because this interface actively tells WPF property changed and tells WPF the name of the property that has changed. We'll take a look at that in a second in code. What about the button? Here we have the button. Do we have a binding from C# to the button? If we dynamically want to change the content of the button, the text which is part of the button, then the button would be nothing special. It would be like a text block. The button is a little bit different when we think about the way back. When the user clicks on the button, and in C# we want to have code that does something when the user clicks on the button. How is that handled? How do we do that? Yeah?
It triggers an event.
It triggers an event. Yes, the button has a click event, and we can register a C# method and tell the button whenever you are clicked, the event happens, then you call the C# method. That is correct. But there is an alternative. Have you ever heard about the ICommand interface? In professional WPF applications, you would not use the event. You would interface, just like here with this INotifyPropertyChanged, you would implement the ICommand interface on a certain class, for instance, and then bind the button to the implementation of ICommand. And ICommand has two capabilities. First, it contains the event, which is triggered when the user clicks on the button. And second, it returns a Boolean value telling WPF whether the button is currently enabled or not. So it combines the clickable property, is this button currently activated? Yes, no. And the event handler. These two things are combined into a single interface. But the Boolean value, you have just in C#, just change the Boolean value and the button will be grayed out. And if you change the Boolean value back, the button will be active again. So it is data binding for the event and the enable-disable of buttons. Why did they do it in that way? Why is it so complicated? What do you think? Oh, we can do a binding to the isEnabled property.
Oh, yeah.
We could do manually the event handling and the binding to the isEnabled property.
Yeah,
that would be super simple. Why do we have a separate interface for that? In Windows applications, the reason is simple. In Windows applications, you typically have multiple ways of triggering a certain event. For instance, you could have a button on the UI, but you could have exactly the same feature sitting behind a menu item. And you can have exactly the same feature sitting behind a keyboard shortcut. Understand what I mean? So therefore, the WPF developers thought it would be a very good idea to build a layer of abstraction. Independent of whether you have a menu item, or a ribbon button, or a regular button, or a keyboard shortcut, you can always use ICommand. Because logically, we are talking about a command that the user gives to the application. And then we can bind this command to different areas of the app, to a menu item, to a button. I think you understand what I mean. Exactly. If you set the Boolean property to false, then automatically the button is disabled, the menu item is disabled, and so on and so on. Okay. Exactly. That's the idea here. Okay? One important tip for your Matura, you do not need the ICommand. We do not expect you to implement that. If you want to make it perfect, then nobody stops you from doing so. But it is not recommended. Okay? Because we will not go into details. We don't have the time in the upcoming weeks. We didn't cover it last year because it is an advanced thing. You typically use a library for that. It's not trivial if you have multiple buttons and a large menu to implement it in this way. So we didn't cover it here in this course, but I still wanted to tell you that in practice you would do exactly that. Right? So what do we have to remember from this chart? We have a powerful 3D-enabled graphics engine behind a desktop app like WPF. You should remember that. WPF knows way more than just a few buttons and list boxes and combo boxes. Next one. We have a logical tree describing the structure of the UI, and we do not have to manually draw pixels on the screen in WPF. We have a templating system, because these things, like a button or a combo box behind the scenes, they are way more than they seem on the first glance. They have a border, they consist of images, they consist of shadows, they consist of, think of a list box, a rectangle, which might be filled in a certain color when the item is selected. So if you just say this is a list box, behind the scenes, a powerful template turns this list box into a finer granular structure. And this is the templating system. For your Matura, we do not expect you to write ad hoc a new control template. This is out of scope. It would be too complicated. You only have 5 or 6 hours, and your WPF part is only part of your exam. So this is just for your interest. WPF is powerful when it comes to templating, more powerful than even HTML and CSS, but we don't need it in the Matura. So in the Matura, it's perfectly fine if you understand how to write that one in XAML. Next step, we have C#. We do not do imperative code, where we grab an element and manually change the text. But what we do, we create bindings, and bindings are real objects. In this case, if we create a binding, the text box does no longer have a text, but the text is in reality a binding object. And the binding object points to the C# property. And if this property, or the class where the property is in, implements INotifyPropertyChanged, we automatically have a binding from here to here to here, and we don't have to do anything. WPF handles everything for us. If we have something like a combo box or a list box or an items control, we don't just need INotifyPropertyChanged, but we need INotifyCollectionChanged. And the simplest thing is using an observable collection, because that does everything for you. Very good question. Let me note that. This is the important one, and your question was, does observable collection just handle adding or removing of items, or does it also automatically handle changes of the properties of the objects inside of the collection? Did I get it right? Yes. Okay. No, it just cares for the content of the collection. You add an item to the collection, and magically the item appears in the combo box. Okay. You remove an element from the collection, and magically the combo box has one element less. But if you add something to the observable collection, let's say a customer, And in the combo box, you display the customer name. And for whatever reason in C#, you change the customer name. Will the customer name be automatically updated in the combo box? No. Only if your customer class implements INotifyPropertyChanged. No, you have an observable collection of customer. That would be a list of all your customers. And the customer, the single customer, has to implement INotifyPropertyChanged. And then everything is fine, because if you add a customer, then ObservableCollection will make sure that the customer is added to the combo box. And the INotifyCollection of the customer will make sure that when the customer name changes, the text in the combo box also changes. So very frequently, you have observable collections containing a list of objects that implements INotifyPropertyChanged. IColllectionChanged contains a collection of things which implement INotifyPropertyChanged, because then you have everything. Then you get full change detection. Students at home, did you understand what I was telling you? Do you have any questions? We will take a look in a few minutes how this looks in code, but first we compare that with Angular.